Good day, everybody. So today we are going to go ahead and review for our test. We're going to start the review. We got our test on Thursday and Friday of this week. So today and Tuesday and Wednesday, I'm going to review a little chunk each time from the unit. I'm going to get you your review assignments today. You should probably be doing a chunk of that every single day also, maybe a third of it every single night or something like that. It'll be due on Thursday, with the day of the test. It'll be a 2-day test. And let's go ahead and start going with it. So work today, way back to the beginning of the unit stuff. So they gave you a function, f of x equals x squared minus 8x plus 12. And they want you to find where its vertex is, the axis of symmetry, and all the zeros while we're at it also. Okay, so this is a good review of everything. First off, how do you find the vertex? If you just want to know where the vertex is, there's lots of ways to do it, but I think the most simple way would be to use this equation right here. We've referenced this many times. X equals negative b over 2a. That's the x coordinate of not only the axis of symmetry, that line that goes through it and flip same on both sides, but it's also where the vertex will be. So if you go apply this to this formula, let's see. B is negative 8, right? So I got negative 8, which would be 8, all over 2a. A is 1. 2 times 1 is 2. And if you're careful with it, make sure you do the signs right and all that kind of stuff. If you mess up the beginning, and everything kind of gets jacked up from there. It's like a system of equations. You get x equals 4. So right off the bat, that is the equation of your axis of symmetry. Your axis of symmetry is a line given by the equation x equals some number. It's a vertical line. Vertical lines are x equals kind of stuff right there. So you know that it's going to be the same on both sides. It's called axis of symmetry because it's symmetric. It's the same exact thing on both sides. So now if I know where the vertex is, it's a 4. This is a good skill to have also for something coming up later. How do you figure out what the y coordinate is? You know it's somewhere on this line, but if you ever need to find the y and you got the x, just take the x and plug it in, right? So if you plug 4 in here, 4 squared would be 16, right? 8 times 4 would be 32. And if you go do all this work, you get negative 4 when you're done with that stuff. So down here at negative 4, that's where my vertex is going to be. Okay? That's how you find a vertex. Go to x equals negative b over 2a. Tells you the axis of symmetry and where the vertex is. All right, good things there. So we've got a vertex. Remember, vertex is just the name of the top or the bottom of this thing. Which way is this probably going to open? How do you tell? It's going to open up. How do you know? Yeah, thing in front's positive, so it's going to open upwards. Now I'm going to try to draw this one more carefully because the directions also say not only find the vertex in the axis of symmetry, but the zeros. What's a zero? A zero is where it crosses the x-axis right there. Lots of words for it. Root, solution, zero, all kinds of things. They all mean the same thing. There's lots of ways to go about doing that. Okay. Number one, if you're trying to figure out when something's equal to 0, you're trying to see when it's equal to 0. So you can set this thing equal to 0. And then if push comes to shove, you can always do quadratic formula. That's what it's there for, to find zeros. But maybe it factors. That's what you should check first. That'd be a lot easier. Does this factor, guys? I think it does. 12, I'm thinking maybe 6s and 2s because they go together to be 8 somehow, but they both got to be negative. So x minus 2 and x minus 6 would be how this would factor. If you can't see it factors, you can always go to quadratic formula. It's a little faster, though, because if you can factor something, then you just got to see when the factors themselves are 0. So if you go off and set equations up, and for something simple like this, you probably wouldn't need to. You could probably spot what makes them 0. But if x minus 2 is 0, that means x is 2. And if x minus 6 is 0, that means x is 6. So that means that coordinates 2 and 6 are on the x-axis. So that's where the zeros are. There's 2 right there. It's going to cross the axis at x equals 2. Also, it's 6. So 5, 6. So now, not only do I have the vertex and the axis of symmetry, but I also know 2 spots where it goes to the axis. I can draw a very nice picture of this thing, pretty to scale, with all the key features on there. I know where the axis of symmetry is. I know where the zeros are. That's pretty darn good for any quadratic. Any questions over that? That's basically, the first section is just, can you find a vertex and things like that. So there's problem number 1. Now, also in the first section, and we didn't do this a lot. So this is something I kind of figured that we're going to forget how to do. For number 2, they're asking you how to find the average rate of change. And that's a long time ago, and we haven't used it since. On the interval -1 to 2. Now, what are they talking about with an average rate of change? What they mean is if you found a point at -1. So where's -1? Here's -1, right? Something like that. maybe up there. There's a point on the graph, correct? Negative 1. And at the other end at 2, which is right there, correct? We already found that. The average rate of change just means what's the slope connecting those two things. So if I had one point on the graph and another point on the graph, the endpoints, negative 1 and 2, how do you find the slope between them? Well, it's got a really fancy equation. Really, it's just an equation for rise over run. It's just saying if you find the difference in the y's up here, which is the rise, right, over the difference in the x's, which is the run, then you can find the average rate of change on this particular interval. Average rate of change is just a buzzword for slope between 2 points. That's all it means. So we're going to find the slope between these 2 points. If you like this formula, let's be very careful here. A represents the number on the left. So which one's on the left here? Negative 1 would be correct. B represents the number on the right, which is 2 in this case. Now, what's f of b and f of a mean? That means the function when you plug in b or the function when you plug in a. So you have to go off and find the y coordinates of these things. What's the function at a? What's the function when I plug in negative 1? Well, if you plug negative 1 into this very carefully, what's negative 1 squared? It's 1, right? 8 times negative 1 would be negative 8, but there's another negative, so that makes it a plus 8. When you put this in your calculator, of course, you have to do this in your brain. And when you plug in negative 1 into this, it's just 12. So you put that all together, you get 21. So that means that this point over here is at the y value of 21. Really, all we're doing is find a coordinate of this. So this point up here on this graph is at the coordinate negative 1, 21. Remember, what do you need to find slope? You just need 2 points, right? So if you plug in one of the endpoints, negative 1, you get out one of the y values. The other one, we actually already should know what we get out when we plug in 2. When you plug 2 into this equation, well, what do you get out? You get out 0 right there. So the other point is 2, 0. So according to this little formula up here, f of b is just 0. When you plugged in 2, you got out 0. If you want to use this fancy equation, you certainly can. Basically, what's it saying is the function of b, the function when you plugged in the right side at 2, which was 0, minus the function at a, what you plugged in when you got the left side, which was 21, over b minus a, which is 2 minus negative 1. And if you do the math on all that, that just turns into negative 7. So the slope, and this is a pretty negative slope right here, appears to be negative 7. If you don't want to use that fancy thing, you don't have to. All you need are 2 points, right? There's a point. There's a point. You just got to know what numbers you're plugging in. You're plugging in the left and the right side. You get out the y values. And you can just do rise over run. For example, this goes down, what, 21, right? When you run over 3, correct? So the rise would be negative 21 over 3, which is negative 7. No matter how you slice it, this thing is negative 7. So average rate of change is just going to mean the slope between 2 points. It's fancy stuff right there. That won't be all over your test, but there'll be a couple points worth for that. So want to review that. We'll review that also during the formal review. All right, last one, number 3. A lot of parts to it. Got a lot of complex numbers. That's kind of where our review will end today. We're going to go through these main skills. If you got complex numbers, I gave them names. I said this one's x, 6 plus 2i. I gave another one called y, and it's negative 1 plus 3i, but didn't really need the names. What I'm really testing over is can you add, subtract, and multiply and divide complex numbers. So part A says x plus y. Well, here's x. And here's y. So x plus y right there. I'm just checking, can we put some like terms together? Because that's really all there is to adding and subtracting complex numbers. Just add and subtract the reals and add and subtract the imaginaries separately and you're done. So if you look at the reals, anything without i's, I see a 6 here and I see a negative 1 there. So 6 plus negative 1 would be 5. So I got 5 reals. As far as imaginary stuff goes, I got 2 i's plus 3 i's is a grand total of 5 i's. So your answer for part A would be 5 plus 5i. Nothing too bad there. Part B isn't much worse. It's just subtraction, x minus y. Be careful when you do subtraction, though. Kids still mess things up, even in pre-calc. It pisses me off. Here's x, right? if you're subtracting y, don't write this. Don't write minus and then literally write y. Because what you're trying to do is subtract all of y. Whatever, if y's got lots of things in it, you better put the things in parentheses. Okay, so there's x minus the whole thing of y. You got to subtract all parts of y, not just the real, but the imaginary part too. The whole complex number gets subtracted. You can probably do it in your head after that point, though. Same kind of deal, reals and imaginaries. Reals, I see 6 reals minus -1 reals. That's 6 plus 1, which is 7. So I got 7 reals. As far as I stuff goes, I see 2 i's minus 3 i's. That's just a negative I. So minus I. And we're all done. That's it. Adding and subtracting. Very straightforward. As long as you remember to subtract the whole thing. Just like substitution. If you don't put parentheses around it when you substitute in, ain't gonna fly. All right, part C is just, can you multiply them? So x times y, definitely need some parentheses on this. Here's all of x times all of y right here. And really just an exercise in distribution. Anybody remember what I squared is? Because that will come up. I squared? -1, very good. All right, so if you know that, then you're fine. Because all you got to do is distribute. No, I squared is -1. Don't forget to change I squared into -1, but if you do that, you're fine. All right, distribute it out. Here we go. 6 times -1 would be -6. 6 times 3i would be 18i. And the 6 has been distributed to both. Then you go to the next term, 2i. Well, 2i times -1 is just -2i. And lastly, there's a lot of things going on in the last one, but let's just go piece by piece. 2 times, well, first of all, positive times positive is positive, right? 2 times 3 is 6, right? And I times I is I squared. So plus 6i squared. And if at this stage you're comfortable already saying, well, that's not plus 6i squared, that's just going to be what? -6, right? That's -1 on the end. So -6 plus 18i minus 2i minus 6 is really what that thing is on the end. The I squared is -1, right? And then all you got to do is clean it up, see if you can combine some like terms, some reals. Let's see, I can see -6 and another -6. That's a grand total of -12. As far as the i's go, I see 18 i's minus 2 i's. That's just 16 i's. So we're all done with that one. Complex numbers in, complex numbers out. Real plus imaginary times a real plus imaginary. Clean it all up, turns into a real plus imaginary. And that's kind of all there is to that one. The last one, the only one you really got to know how to do is how do you divide complex numbers? And there's a trick to it. It says x divided by y. So more traditionally, you would write it like this, something over that or something. Anybody remember the trick? What to do with this? There's a special word, starts with a C. Yes, that is correct. Your job when you're dividing complex numbers is to make the bottom pretty. And what makes complex numbers pretty is multiplying them by their conjugate. So the conjugate is the exact same number with the sign of the imaginary part changed. So this was a plus. I'm going to change it to a minus. So literally you just write the same thing, but you change the sign of the imaginary part. Whenever you get a common denominator or multiplying a fraction through by something, you got to do it on the top and the bottom. So unfortunately, you have to do it at the top also, which is where the work is going to be. We're going to have to multiply these tops together, multiply these bottoms together. And it's like 2 multiplication problems in one. Because how you multiply fractions straight across, right? Well, I got this whole thing here times this whole thing there. That's going to require some distribution. And same thing on the bottom. This whole thing times this whole thing will take some distribution. So it just takes some patience. Not necessarily hard, just tedious. All right, let's do the top. Distributing this out, 6 times -1 is -6. 6 times -3i is -18i. And the 6 has been distributed. Moving on to the the 2i times -1 is -2i. And lastly, 2i times -3i is -6i squared. Almost similar to the last problem, but there's a slight difference in this. All right, same thing on the bottom. Now the bottom's going to be prettier, though. You know, with the conjugate stuff, all the I stuff is going to cancel out. It's going to be nice and pretty, but we'll have to see why. -1 times -1 is 1. Moving right along. -1 times -3i would be +3i, so plus 3i there. But here's what's cool about the conjugate. The very next thing when you distribute, this +3i times this -1 is going to be -3i. And you can always see that in your distribution as you go. you can see these two middle things are going to just cancel out right as you go. We're not done. We got the last one too. This times this, nice and slow. A positive times a negative is a negative. 3 times 3 is 9. And I times I is known as I squared. So nice and slow, just distribute it out. Now let's see what we can clean up. On the top, first off, I squared is -1, right? So really this is positive 6, correct? If this is positive 6 and this is negative 6, don't they just cancel out? Well, that's sweet. So I really don't need to worry about those two. The only thing left on top is a negative 18i minus a 2i, which is negative 20i. So there's a negative 20i on top. That didn't work out as bad as we thought. Down on the bottom, as promised, with the conjugates, these two middle terms are going to cancel out. We're left with 1 minus 9i squared, but I squared again is -1, right? So this is positive 9, which plus 1 is 10. So finally, we're getting negative 20i over 10. And make sure on your test you are reducing any fractions you can. If you see something on the top and the bottom that can be reduced, if the I wasn't there, I hope you call that -2, right? Well, just call it -2i. Negative 20 divided by 10 reduces to -2. And that's all there is to it. So that's the skills we're going to be reviewing today. We're going to do our learning goals and then get you guys reviewed on that. That was a pretty comprehensive review, but we'll do some specific problems. Definitely want to talk about average rate of change. Get you guys your review assignment. Yes, you may. I like to give it a shot, not for official grade, but just for see what you got. So review packet ain't that fat this time. You're welcome. They do take time, though. Very comprehensive. They like to put a lot of different skills in every single unit. So there's a lot of things to cover. But today we're just going to review the things we did in the warm-up. So can you find a vertex? Can you find axis of symmetry? Can you do the average rate of change? That's probably going to take some practice, I think. And can you work with complex numbers? Essentially, that's what we're talking about today. Test is on Thursday, as already mentioned. So this is homework 3.9. 3.8 is due today. So if you want to turn that on paper, that's fine. Of course, if you want to do it online, that's your prerogative also. Either way, by 3 o'clock, that's due. It's 3.9 due on Thursday. Test is on Thursday and Friday of this week. So that's what we're working on. All right, here we go. Review time. Focus up. We'll see what we can do. So unit 3 was all about quadratic functions. Very important function to study here. The first section was about just graphing them, which wasn't too exciting. You just need to know the key features again. So like I already said in the warm-up, you have this invisible line, this dashed line right through the middle of a quadratic called your axis of symmetry. It is given by that one equation. If you look down at the very bottom or in the middle right here, it says x equals -b over 2a. So cannot overemphasize the usefulness of that particular formula right there. X equals -b over 2a. Very, very important. And just to remind you one more time, any quadratic, the actual equation of this is x equals some number. X equals some number. So if I say, what's the axis of symmetry? Don't say 4. Okay, if the number is 4, don't say x equals. You gotta say x equals 4. It's a line, right? Lines are x equals kind of stuff. So make sure you write x equals. If you want to find the vertex, it'd be somewhere on this line. The question is, what y value would that be at? And you guys should know by now, if I ask you to find the y coordinate of something, and you know the x coordinate, what do? You just take the x coordinate and plug it in, correct? Spits out some y value, correct? And then whatever that is, that's where my vertex is. So that should be pretty darn straightforward. The only other thing from this section was the darn axis of symmetry stuff. Not axis of symmetry, excuse me, the average rate of change. So let's go over that real quick. If I ask you for the average rate of change on a specific interval, let's try to write some steps out for you because I think it's kind of confusing. Steps to find average rate of change, which really just means slope. So I never gave you a little crash course on this before, but I'll do it right now. And we'll say this is on some interval. They'll give you some interval, say A to B or something like that. Between 1 and 3, between 5 and 9 or something like that. A and B, that's what they represent. Okay, so find the value of the function at A. So whatever the left side is, find the value of the function at that. Step 2, do the exact same thing at B. And what you do is, you know what the two coordinates are here. Say, hey, here's A and here's B or something like that. What you're really just finding there is you're finding the y coordinates at those spots. So if they say between A and B, what's the slope between 2 points right here? Well, you need, how do you find slope? Rise over run, right? So you got to know the y's and the x's. When you plug in A, what you get out is f of A. That's what you get out from number 1. So this gives you f of A. That's what f of A means. It means what do you get out when you plug in A right there. When you plug in B, it's going to give you out whatever the function is when you plug in B. So same thing here. This gives you f of B. And then you just use this equation. M stands for slope. This is slope, right? Slope between two things. Got a secant line. It's called a secant line. A secant line is a fancy word for a line that connects 2 points. So it's just a line that connects 2 points. But it's just rise over run. So, I mean, keep it simple. What is slope? It's rise over run. You got 2 points, right? Here's a point. There's a point. You can just find slope. You want to get all fancy with it, they give you this formula to take the thought out of it for you, but then you got to know everything in the formula stands for. Saying what's f of B stand for, what's f of A stand for, and all kind of jazz. And that's about it. Let's do a problem or so and model this stuff. I don't want to just leave you hanging. Look through numbers 1 through 3. Not that many to choose from. Anybody want a specific number? 1 through 3? Anything? Pick one. I'll pick one. 3. Let's do 3. Okay. So we're going to do 3 together. All right. It says first things first. What's the function? It's x squared minus 4x plus 3. On this section, my job is to find the axis of symmetry. And as already stated many, many times, when they ask you for axis of symmetry, they ask you for the vertex. What you pop to your mind is x equals negative b over 2a. Same thing we did in the warm-up. So for this particular function, b is negative 4, correct? And a is 1. So if you carefully plug them in and are good with your signs, on the top, a negative 4 is a 4. On the bottom, 2 times 1 is 2. So you know this thing is add to 2. And you see this slot that says axis of symmetry. It says x equals, right? Right? X equals 2, right there. You just put 2. So it just says, so you know, on the graph provided also, you should draw a little dashed line that x equals 2. And that's what your axis of symmetry is going to be. You say your axis of symmetry is 2. I'm going to look on your graph and make sure you have some kind of dashed line at 2. And that's about it. Now, vertex. The nice thing about the vertex is you already know it's somewhere on this line. The question is what y coordinate. So you have to take the x, right, and plug it back in to get out the y. So if you plug 2 in here, 2 squared is 4, right? 4 times 2 is 8, right? And 4 minus 8 is negative 4, and negative 4 plus 3 is negative 1. So down here at negative 1 is my vertex. And since they had a slot for vertex, you should tell me where the vertex is. The vertex is a point, right? So write as a coordinate. So make sure you're using parentheses and stuff like this. So you would say for vertex in the vertex slot, you would say the coordinate is 2, comma, negative 1. That thing's x is 2. Should be the exact same x as the axis of symmetry, right? It should be the same exact x as before. You'd have to go one step further and figure out the y's. Now that's it. All I have to do besides that is draw a rough sketch of this graph. Now this opens up. Would you concur? So I'm not going to pick on you. There's nothing saying you have to go find the zeros or where it crosses the axis exactly. So all you got to do is just do a little rough sketch in this section of something that opens upwards, and I'm happy. Opens up. Life is good. We're okay. Now let's practice that average rate of change thing. They're saying the average rate of change on the interval 0 to 2. So going back to what all this stuff means for average rate of change, A always represents the left side, okay, which is 0. And B always represents on the right side, which is 2. The only thing you really need to know is what the functions are at 0 and at 2 right here, f of B and f of A. So let's go ahead and do the easy way. Let's just do rise over 1. First off, the 2 points I'm going to use, one's going to start with 0, the other one's going to start with 2. And that's the x coordinates they gave me. You're doing the ends. So you're trying to find from right here to right there what the slope is in between them right there. And we just need coordinates for these points. All right, so at 0, let's see what it is at 0. How do you figure out what this y value is up here at 0? Well, you plug 0 into the equation, right? Plug 0 in, you get out 3, right? So you know this point up here is at the coordinate 0, 3. Similarly, if you want to know what the y coordinates for the 2, well, let's see. We already figured it out, didn't we? It was -1. So it's -1. And if we didn't have it figured out already, I'd just take 2 and plug it in and get out some other kind of y. So here's my points. Here's A, here's f of A, here's B, here's f of B. So you can just plug in your equation right now. Or you can just do rise over run. Doesn't really matter to me. Difference in the y's over difference in the x's. It doesn't matter. It's all the same thing as slope. We can just do rise over run. Let's do the y's. What's this y minus that y? 3 minus -1 would be 4, correct? This minus that, right? Changes in the y's. And then that minus that, make sure you go in the same order. 0 minus 2 would be -2. Apparently, the slope between these 2 points is -2. Or if you want to be all formal with it, you can use their little handy formula. Remember, this is A and this is B. So what's f of B? What's the function when you plugged in B? You got out -1, right? What's the function when you plugged in A? Well, when you plugged in 0, you got out 3, right? And down the bottom, what's B minus A? Well, what's 2 minus 0? That's asking. Turns out to be the exact same thing. You get -4 over 2, which it still reduces to -2. So average rate of change, really all you're trying to do is find the slope between 2 points, okay? The interval I give you, in this case, 0 to 2, are the x coordinates of those points. 0 is one of the x's, the other x is 2. And if you need to find the y's, go plug them in. Then you got coordinates, and you can just do rise over run and figure out the slope right there. Make sure it makes sense, too. I mean, look at this picture. This is going down, correct? Should have a negative slope. Do I have a negative slope? Yeah, so everything kind of makes sense, and life is good. So that's all there is to that one. Now, other stuff. Section 3.2. This is about solving quadratic equations by graphing. This is probably the dumbest thing on the test. If you turn over your page to numbers 4, 5, and 6, they have good models of that. Essentially, all you have to do to solve anything by graphing, no matter what it is, quadratic, cubic, linear, anything, absolute value equations, we already did, anything, is just set it equal to 0, graph it, and see where it crosses the axis, because that's what 0 is. That's the whole review for this section. So 4, 5, and 6 do that. Let's pick one of them at random. You guys, anyone looks particularly scary or? Good pick. Smart man picking things. All right, we'll do number 6. So it's the most complicated because I put things on different sides just to kind of jack with you. You know, it's pretty. Takes a couple steps to get everything equal to 0. So let's look at that. Yeah, get equal to 0. Doesn't really matter which side's 0. What do you feel like? Which side do you feel like having to be 0? Left or right? Pick one. Left is going to be 0. All right. So if left is going to be 0, we're going to move all this stuff over. We're going to have to add 6x to both sides. So if I add a 6x to the right, now it's got a 6x in it. Now that one's gone. And you get rid of the -3 also, right? So adding 3 to both sides, -10 plus 3 is -7. So this is my thing. And now you need to go graph it. That's the whole point of this thing. Get your calculator out. And remember, you're just graphing that. You just want to see that thing and see where it crosses the axis. Where does it equal 0? Ew. I do not think they're going to be pretty. Ew. According to my mental math, and when you graph it, you should obviously look to see a quadratic, right? I mean, it's an x squared kind of thing, so it just opens up. It should look something like this. And remember, you're trying to figure out it equals 0, so you learn how to do that. Second calc, right? Second calc, 0. Second calc, 0. That's for a left bound. Go somewhere to the left of where it crosses the axis. Go somewhere to the right of where it crosses the axis. And guess doesn't really matter. Hit enter. And it should zoom in on this number. Am I right or wrong? Is the first one -4 point? Well, well, what did I do wrong? You're right. What the heck am I doing? Oh, whoops. I'm using my quadratic formula wrong. Don't look at that. You never saw that. What were the numbers again? Nice and pretty. -1 and -7. That seems 1 and -7. All right, that makes more sense because that actually does factor. You could check. Yeah, what am I doing? If you want to check, you can always simply use your old skills. I mean, does this thing factor? In fact, it does. Yeah, it's x plus 7 and x minus 1. The two zeros should be -7 and 1. If you're getting some other weird decimal thing, you're probably doing something wrong, and you should stop and ask yourself, what am I doing up here? And that's what I'm asking myself right now. But that's it. That's all there is to graphing something. Okay, set it equal to 0 and graph it. See where it crosses the axis, and whatever the x values are, you just write them down. So the slot that says x equals, you write them down. Make sure you do a rough sketch of the curve. Whenever there's a graph provided, make sure you kind of hit the highlights of it. What's the highlight of this graph? I don't really care where the vertex is. I care where it's 0, correct? So as long as you're showing it crossing -7 and 1, we're pretty good. I'm not going to sit there with a microscope and make sure this is the right spot or anything like that. Nice rough sketches, all I request. Cool on that? Any questions over solving by graphing? Pretty straightforward. Okay, and then the very last thing to review today is just kind of complex numbers again. And we already talked about them. So what is a complex number? It's got i's in it. What is I? It's the square root of -1. We've invented it because we can't find square roots of negatives. So it's a brand new kind of number that we haven't used a lot in lower real analysis kind of courses, but nonetheless, it's here now. Things you should know about I. Well, you should know anything to the 0 power is 1. Okay, that's good to know. I don't think it's going to come up in your work anywhere there's an I to the 0, but if it did, it's 1. Well, then you're going to come up with this bottom one, I squared, which is -1. So you need to memorize that. If you can memorize that, you can build up all kinds of things. For example, if somebody said, what's I to the 6th? Well, that looks complicated. What does that mean, I to the 6th? It means I times itself how many times? 6 times. So if you write out 6 times, that's a lot of i's, but just break it into little pieces. That's all we do in this class is break it down to smaller things we know. What about 2 i's together? What's that called? That's I squared, right? Which is what? -1. So I can call these two together a -1, correct? What about these two together? That's another I squared. That's another -1, right? Oh, here's another couple. So guess what that is? That's -1. And what's -1 times -1 times -1? It's -1. So I've logically kind of figured out what bigger powers are based on smaller things I know, in case that does come up. Besides that, you need to know how to add and subtract them and that kind of stuff. We kind of reviewed that in the warm-up already. When you add and subtract them, just add and subtract the real part separately. So for example, if I had this kind of format right here, a plus bi plus or minus c plus di, well, let's just pretend this is a plus right here. What's the real part of this one? A, right? What's the real part of this one? C, right? So I'd add those together. It's a plus c. That's what this fancy formula is saying right here. Oh, what about the imaginary stuff? Well, you got imaginary here, you got imaginary here, you add them together. Well, I got bi's plus di's, maybe I got b plus di's or something like that. For multiplication, all you got to do is FOIL it out, okay? Just normal distribution kind of stuff. And when you do, remember I squared is -1. And probably the hardest thing to remember is you have to, when you do division, you have to do the complex conjugate. You have to do the conjugate of the bottom, whatever the bottom is. If it's c plus di, then you should multiply the top and bottom by its conjugate, which would be c minus di kind of stuff. And if it's a c minus di, you'd multiply by c plus di kind of things. And that's really all there is to working with complex numbers. So let's pick a couple of those and we'll call it a day. Number 7 through 15. Pick a couple of them. We'll model those. And we'll let you guys work. Any questions over anything we've reviewed so far today? Okay. Any ones look particularly scary? 12. Yep. You asked for the tough ones, which is smart. I would do that also. All right. Yeah, this is probably one of the only ones that's really difficult. The rest are just distribution. Be really careful with signs and little things. That's what always gets everybody all the tests. Number 12, we're asking for 5 plus 6i divided by 2 plus 3i. Well, you just got to know how to do it. You have to multiply the top and bottom by the conjugate of the bottom. If you know that, then you'll be fine. If you don't, you're just going to sit there and spin your wheels and make up rules and just jack up the whole problem. But the conjugate of the bottom would be 2 minus 3i. So again, conjugate just means the exact same number with the sign of the imaginary part changed right there. So if we had 2 plus 3i, its conjugate should be 2 minus 3i. And you have to do it on the top too. The benefits will be that the bottom will be pretty. The top will probably be some gross thing, but that's okay. Our job is to make the bottom pretty. That's why we're multiplying by the conjugate of the bottom. So I want the bottom to be pretty. All right. Well, how do you multiply fractions? Straight across. Don't forget your basics, okay? The basics always follow you the rest of your life. Multiply straight across. Unfortunately, I got this thing times this thing, which means I have to go distribute it all out. So carefully, 5 times 2 is 10. 5 times negative 3i would be negative 15i. Moving on to the 6i. 6i times 2 is 12i. And lastly, go really slow on that last one. I would strongly encourage you not to try to do too much in your head at once. First things first, I got a 6 times a negative 3. That's a negative 18. And you also have an I times an I, which is an I squared. Don't forget to write I squared. Don't just write I or something like that. Be careful with that. I times I is I squared. We could have just called that plus 18 at this step, but I strongly encourage you just to write it out like this, and then we'll take care of that in the next subsequent steps. Down the bottom, same kind of deal. 2 times 2 is 4. 2 times negative 3i is negative 6i, but the cool thing about the conjugate is the very next thing that's going to happen is the 3i times the 2 is going to be a positive 6i. You should always see that second and third thing you write down about to cancel out. That's the point. Otherwise, what's all still on the bottom to do is 3i times negative 3i. Well, again, let's go nice and slow. A positive times a negative is negative. 3 times 3 is 9. And again, we have an I times an I, which is an I squared. So we distributed it all out. Kind of a pain in the butt, but we did it. Let's keep working it. So on top, like I said, this I squared is really a negative 1, right? So this isn't really minus 18. This is really plus 18. And 18 plus 10 is 28. So on the top, there's a 28. Now, the other things that were left over, the i's, we kind of took care of this dude and this dude, put them together. On the other two, negative 15 i's plus 12 i's would be negative 3 i's. So I've got negative 3i on top. Down on bottom, cleaning this thing up, as promised, these two middle dudes will cancel out. We don't need to worry about them. That's sweet. Over far on the right, we got another I squared, which is negative 1, right? So this isn't really minus 9, it's plus 9. And 9 plus 4 is 13. So we're good on that. Only other thing to do is check, can I simplify it any? Can I reduce? Does anything go into all three of these numbers? I don't think so, right? So I think we're pretty much good to go with that. That's a fine answer. I'll take that. If you want to split it into two different fractions, the real part plus the imaginary part, that's fine with me. I kind of prefer that. I won't make you go that far. If you get to this stage, you did a heck of a job already, and I'll give you full credit. But I prefer the very bottom one even better. All right, good. Very good on that one. Any other ones you guys want to see real quick? Maybe you're good, huh? You good for the day? Probably good for the day. All right, so that concludes the first third of your review. We will be moving on from that starting tomorrow. That was basically everything. That's numbers 1 through 15 on this. So your goal tonight, if you want to stay on task and make sure this doesn't creep up on you, and really make sure you get it down. You know, if there's anything you don't get on numbers 1 through 15 for tomorrow, that's okay. But come and ask me, because we don't want to be asking the day of the test and all that jazz. So that's all for today. Get working on it, guys. Don't forget 3.8 is due and 3.9 due on Thursday.